Welcome to Solving Systems, Task 3 with matrices. In this task, you're going to be working with systems of equations and using those systems to solve, and using matrices to solve those systems. As you can see, we're going to use these first matrices and the matrix equation, or the first system and the matrix equation, to solve this system. Notice we have A times X plus B times Y to equal C. And in our matrix, which is a 2 by 2, a 2 by 1, and 2 by 1, in our matrix equation, we have the A followed by the B, which comes in order. Now notice the X comes before Y, so then we're going to find out an X and a Y to equal our C. Okay? Then we're going to go down to the next equation, a part of the system, the D, the E. The X and Y still stay because, again, you had X that shows before Y, equal to your F. Now, if we were to treat this matrix equation like a normal equation, a linear one, say it was 2x equals 8, we would divide 2 on both sides, and we would get x equals 4. So if that were the case, we can't really divide with matrices, but what we do is we have two matrices equals something, another one. We would multiply the inverse of matrix C, that's why they have this C to the negative 1 times C, which would kind of give us a canceling out, but it's more of an identity matrix, you know, the 1, 0, 0, 1. If you don't know what I was referring to, make sure you look up identity matrices. But when you multiply the identity matrix on the left, you also, the inverse on the left, you also multiply that inverse on the right, and the inverse of C times A would give you a solution. Okay? So for instance, if we got this in our calculators or with our arithmetic, then we was saying that our X was 2 and our Y is 3. So let's look at what happens with an actual system. Okay, notice they started with a 2 variable system, X and Y. X came first. So the 5, the negative 1, which is the coefficient of this negative Y, again your XY was 7. The 2, 3, XY with negative 1. Multiply the inverse on the left side and the inverse on the right side. All of this ends up canceling out, so you have your XY equals your inverse times your original solutions matrix. And that solutions matrix is pretty much the 7, negative 1 that was like at the right side of your original system of equations. Here's a 3 by 3, and in that 3 by 3, of course, you set up a 3 by 3 matrix. Well, it's 3 variable, but you set up a 3 by 3 matrix. Your 3 by 1 for your X, Y, and in this case, your Z, equal to your solutions matrix, 3, 8, negative 22, and you go on from there. Other than that, there's a whole bunch of practice. Then you get into writing a, a system for linear equations, which kind of parlays into writing a system for variables. Okay? So I want you to, I want you to think about how this enables a person to come up with this. So say I gave you A times X squared plus BX plus C equals a number. Of course, this is the general rule or the general form of quadratics. You would then need to use your graph, do something with the x's, and once you did all of that, you can then find out what the A, the B, and the C was. Okay? So, because that's at the end of the day the important thing. Once you find the A, B, and C, you then have the formula for the parabola. If you have any questions, please be sure to ask your online teacher.